This video is for the back of Chapter 29, Practice 5. So here we have an object, and here are two incident rays coming from it. So this might be an object giving off light. It might be giving off light in all directions, or it might be something that's reflecting light. There's something shining light on it, and light has bounced off of it, but it's going to this mirror now. So I have two incident rays, and I want to find where the image is. So of course this black line is representing my mirror. I'm going to draw a normal where the incident ray hits the mirror. So I'm landing my protractor this way. You should be working along with me and pausing the video when you need to work. So I'm going to mark off the 90 degrees. And later on, you'll see that my normal looks horrible. And you can see exactly why right here. See how I'm not exactly lined up? I have my protractor a little low. This should have been up here exactly where that hits. I wish I could redo this. So you're going to use a straight edge, either a ruler or your protractor, to draw your normal. And that is a dotted line. I'm just going to use my dotted line tool on the board. Ugh, that looks horrible. And then you will measure the angle of incidence. So I'm measuring, so 10, 20, 2. I'm not going to write that anywhere. I'm just going to remember that in my head. So if the ray came in at 22 degrees on this side, it's going to reflect 22 degrees on the other side of the normal. That's what the law of reflection says. So I'm marking off the same angle I had. So now I should use a ruler or straight edge to draw my reflected ray. I have the incident ray, it hit the mirror, exactly where it hit, I draw normal, and remember this one looks horrible. I measure the angle of incidence with the protractor, and whatever that angle is, I mark on the other side. That looks pretty bad too, because I think I said this is 22, but the one I did this, I did 24. But you're trying to be as careful as possible on yours. Now here's the new step. Your eye doesn't know that light bends. Your eye, your brain interprets that light goes in a straight line. Your eye doesn't know the light came from here and bounced off the mirror. Your eye thinks it sees something back here. So that's the new step. We're going to take this reflected ray and extend it back beyond the mirror. And that's going to be a dotted line. Because remember in this chapter, when something's real, it's a solid line. When something isn't really there, it's a dotted line. Because remember here, the normal, there's nothing really here. I just drew that as a reference to measure my angles from. Back here, there's not really going to be light back here behind the mirror. It's just that's what your brain interprets. Your brain thinks you see something back here. Now make sure you're using a long straight edge, maybe the edge of a piece of paper if you don't have a ruler. But it has to be straight. Make sure it doesn't tilt here. So you'd line up your ruler like this. And I can't really draw the line on the ruler, so I'm going to use my straight line tool. Incident ray, reflected ray, and it's the reflected ray that I'm going to extend straight back behind the mirror. I'm just making sure that I'm lined up. I'm using my straight line tool and just making sure I'm lined up with the reflected ray. So you can't tell where the image is yet. You need to do another ray from the same object. So I'm going to mark off a normal for this one. This one looks a little better. Mark it off my 90. You can tell I have my protractor lined up a little better this time. I would use a straight edge. Make sure my normal is perpendicular. Now I'm going to measure my angle of incidence. Get my vertex lined up. I gotta get a 0 lined up. It's hard to get it exact on here. And now you can tell that's like 10, 20, 30, 40, 7 degrees. So I want 47 degrees on the other side. So 10, 20, 30, 40, 7 degrees on this side. Oh, my little mark didn't quite fit on the screen that I was recording. So I'm drawing that to that little mark that I made. So it's the same angle it came in at. The angle of incidence equals the angle of reflection. And now remember, it's the reflected ray that I extend past the mirror. Dotted lines. So now I can tell where the image is. The image is where they cross. My brain tells me it saw something back here. That is a virtual image. And that's virtual because there's not really light rays back here. What the real light did was it came and bounced off the mirror back here to your eye. But your eye thinks, or your brain thinks, that that light really came from back here. Okay, now here I'm going to describe how to do the, I think I call it law of reflection practice. There's a shape on one half of the page. There's a line that represents the mirrored line. And then you are to find the image of that shape by doing ray tracing. You need to do the ray diagram. Every ray of light. So I know this doesn't look exactly like the shape on the paper, but I didn't scan it and put it in. So anyway, so this is some kind of 5-sided shape. And I could find the image of that if I find where every corner of that is located. So I'm just going to go one corner at a time and find the image of it on this side of the mirror. I'm going to start with this one. So everything for this corner I'm going to do in red. Some people like to do that, like kind of color code it, because this is going to get pretty complicated. There's going to be rays of light all over the place, and you need to know where each ray came from. So the rays that come from this corner I'm going to draw in red, so I will know. So first of all, I need to draw 2 incident rays. Remember in that last example, I didn't know where the image was until I did 2 rays of light, and then I could tell where they crossed. Where they intersected, that was where the image was. So I'm going to do 2 rays from this red dot. And it doesn't matter. It doesn't matter where that hits. I just need a ray to come hit the mirror. I can hit there, or there, or there. But I do not want to bring it straight down. So do take it off to the side. So there's going to be my 1 ray. And here's going to be my other. I'm going to bring it way over here. It doesn't matter. It doesn't matter where you have it. You just find a clean spot on the mirror. I'm going to draw a normal for each one of these. I'm marking off my 90. I'm going to slide down here and mark off this 90 while I'm at it. Going to get a ruler or straight edge to draw those normals. Dotted. I'm going to double check these, make sure I love them. Yeah, that's pretty good. Yeah, maybe I agree. That's probably good too. So I have my normals. So incident rays, normals, and I'm going to measure the angle of incidence. Remember, the whole reason I drew the normal is because that's what I measure the angles from. So it looks like this one is 10, 20, 30, 40, 50, almost 60, maybe 58. So 58 degrees on this side. So I need 58 degrees on the other side of the normal. $58. I'm just remembering that in my head. 10, 20, 30, 40, 58. So I'm marking off at 58. Oh, that's cool. Kind of drew it for me. Just going to make that darker and longer. So notice I didn't write 58 degrees here. There's going to be lines all over the place. I don't want to clutter it up with my numbers. But I did measure this was 58 degrees on this side of the normal. So it's 58 degrees on that side of the normal when it reflects. That's what the law of reflection says. I'm ready to do this one. I'll measure this angle of incidence. And then on the other side of the normal, I'll do the same angle. There, so this looks like this is my 0, 10, 20, 30, maybe 34 degrees on this side of the normal. So now I went 36 on this side. 10, 20, 30, 6 degrees over here. Okay, so now I have 2 from that same corner. Incident ray, normal, reflected ray, and over here. Incident ray, my normal, my reflected ray. Now it's kind of hard to do it on the board like I'm doing. See how this corner's a little sloppy? Like this one should be maybe over a hair or something. This one looks better. But you want to be as careful and exact as you can on these so your sketches turn out well. So now remember, it's the reflected rays that I extend. I don't need to draw those arrows, but that reminds me, what is my reflected ray? So I'm extending that back straight, and I'm extending this one back straight. Use a ruler so you know it's straight. And now where they intersect, where they cross, that's the image of that one corner. So I'm just done with one corner. Got 4 more corners to go. Just for the sake of time, I'm just gonna quick eyeball and freehand this corner. So this is my blue dot. I'm gonna draw everything in blue for this one. Incident ray, remember it doesn't matter where it hits. Incident ray, doesn't matter where it hits. Normal for each one of those. Of course, I'd mark off 90. I measure the angle of incidence, and then I draw the angle of reflection on the other side. Extend that straight. Ugh, you can tell it's not too straight. Incident ray, measure the angle, mark it off. Reflected ray, extend it. Yikes. So where those intersect would be my blue one. And then I'd go and do another corner. You can see I have lines all over top of each other. So I got to keep track of where each line came from. So that would be my pink corner. I need 2 incident rays. There's a clean spot in the mirror. Remember, don't take it straight down. There's a clean spot on the mirror. For each one of those, I'd mark off a 90 and draw a good normal. I'd measure each of those angle of incidence, mark off the same angle on the other side for the angle of reflection. I'm just eyeballing this. There's my reflected ray. Over here, there's my reflected ray. Then I extend those with dotted lines because it's not really light rays back here. Straight edge. The other one from the pink dot. Extending that straight. Where they intersect is the image of the pink corner. There's my image. And now I have 2 more corners to do. Let's say I could do this corner in green. 2 rays from that. And I could do this one in brown. You just find a clean spot of the mirror. So I'm not going to finish this one, but that's how you'll do the law of reflection practice. I'll show this in class. I just wanted to show you so that it doesn't matter where the first line goes. It doesn't matter where your 2 incident rays go. So like here, if I drew my incident ray there, my normal, my reflected ray, extend. I could draw one here. It could go the same way. Incident ray, normal, reflected ray, extend. They could go the same way. Incident ray, normal, reflected ray, extend. Incident ray, normal, reflected ray, extend. You can tell it didn't matter where that first incident ray was. They all cross exactly here because that's where the image of that dot is. So that's why it didn't matter where you drew those first two. Now you don't have to do 4 of them. Remember, as long as you do 2, wherever they cross is where the image is. Oh no, this barely fit. Okay, I didn't quite make my recording area big enough. But if I want to do something complicated like the letter F, if I could just find the image of every corner of that, I could do it. So here we go. Incident ray, normal. It didn't fit on the screen. Reflected ray, extend. From that same dot, that's my blue dot. Incident ray, normal. Reflected ray, extend. So that's the image of that dot. Now I do another dot. I'm going to switch colors. Incident ray, normal. Reflected ray, extend. Incident ray, normal. Reflected ray, extend. There's the image of that dot. Incident ray, normal. Reflected ray. Remember, you gotta use a protractor to measure these. You're not just eyeballing anything. Extend. Incident ray, normal. Reflected ray, extend. That's the image of that one. And you can tell if I kept going, if I kept doing every one of these dots, you can see here why something looks reversed in a mirror.